Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and today we are going to talk about translations of functions. In this video, we'll break down horizontal and vertical translations. You'll learn how to create new graphs from an equation, as well as translating existing graphs. So let's jump in with a Desmos demonstration. Many of you will recognize this graph here. This is your basic quadratics. It is f of x is equal to x squared. So here, this is the red graph. We have another graph here, which is f of x minus p plus q. So we have added the minus p into our function f, and we're adding a plus q after the function. So for now, I have set p and q values to be 0. So which means this is just f of x. So I'm going to turn on this graph. You'll see that it is the blue graph and it completely overlays the red graph. So again, this is the original f of x is equal to x squared, and this is f of x minus p plus q. So now let's see what happens as we switch up the p and q values. So let's start with q first. So if I drag the slider here and increase my q value, you can see that the graph, the blue graph, is shifting up. And if I drag it to negative value, it is now below the original function f of x is equal to x squared. So this is what we call a vertical translation. Next, we are going to change our p-value. So if I were to increase my p-value, see how the blue graph is now shifting towards the right. Similarly, if I make my p-value negative, it is shifting towards the left compared to the original graph. So let's say we want our p-value to be 3, and we want our q-value to be 2. What this means is we have shifted our original graph, which is f of x is equal to x squared. We've shifted 3 units to the right and 2 units up. So that is what this 3 and 2 represent. The p-value represents the horizontal shift, and the q-value represents the vertical shift. Now let's take a look at another example. So let's reset our p and q values back to 0. And then we will turn off these graphs. Okay, so here we have another graph. And similarly, we're going to perform translations on this graph. So we would have g of x minus p plus q. So again, let's go ahead and take a look what happens when we change our q value here. Okay, so the purple graph is the original graph, and then the black graph is what happens when we change our q value. So again, when we increase our q, you can see that the graph is sliding upwards. And similarly, if our q becomes negative, then the graph goes below the original graph. So it's a vertical translation down. And if we were to change our p-value, it's going to shift this graph to the right if p is positive, and then shift the graph to the left if p is negative. So if again, we want our q value to be 2 and our p value to be 3, you can see that it shifts our original graph, which is the purple one, 3 units to the right and 2 units up. So let's go ahead and generalize this. If we have y is equal to f of x minus p plus q, what that means is our function f of x has been transformed in the following way. So first, f of x has been shifted horizontally by p units. Next, f of x has been shifted vertically by q units. More specifically, if our p-value is greater than 0, so meaning if it's positive, then f of x has shifted to the right. And if p is a negative value, then f of x has shifted to the left. And for a q, if q is greater than 0, meaning if q is positive, then f of x shifts upward. If q is negative, then f of x shifts downwards. So thinking back to our demonstration, we had our p-value was 3 and our q-value was 2, which is why it shifted our original function 3 units to the right and 2 units up. One thing that you have to be careful of is notice how here for p, it's a negative sign, whereas for q, it's plus q. Okay, so let's go ahead and apply this knowledge to an example. So now, given that we have our function f of x is equal to the square root of x, and we've drawn the curve on this paper here, we want to sketch g of x is equal to f of x plus 2 minus 3. So let's go ahead and write down what the general form was. So it was f of x minus p plus q. Okay, so if we compare what we have here to this general form, we can see that our p-value is negative 2, because we would need to write f of x minus negative 2, so that it becomes x plus 2. And then our p-value is negative 3 because we're adding negative 3. So this tells us that our p-value is negative 2 and our q-value is negative 3. So what that means is we're going to have our original graph is going to be shifted 2 units to the left and 3 units down. Okay, so let's start with this point here. It's going to shift 2 units to the left and 3 units down, which means it's going to end up here. And then our 1, 1, this point here, is also going to shift 2 units to the left and 3 units down. So it's going to end up here, which means our new graph is going to look something like this. So this red curve is the graph of our new function, which is y is equal to g of x, which is f of x plus 2 minus 3. So let's recap what we have just learned. P-value is the value that's inside the function. And what it does is it shifts the graph left and right. And remember, it is the opposite sign. The q-value is a value that is outside the function. And what that does is it shifts the graph up and down. And it's the same sign. Okay, so now, using this knowledge, can you determine what transformations have occurred in this example here? So we have our g of x, which is the original function, and it's equal to 1 over x. And we have our transformed function, which is h of x, and it's equal to 7 plus 1 over x minus 5. So leave your answer in the comments below and let us know if you'd like to see more content on translations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.